I want you to picture the standard bell curve. You know the one I'm talking about, right? High in the middle, then it tapers off.
Mm-hmm.
Now just map that curve onto human feet. Most of the world, I mean the vast majority, lives right there in the middle.
That's your standard D-width.
Exactly.
Yeah.
That's the person who walks into any shoe store, grabs a box, slips it on, and they're out the door. It's a thoughtless experience.
And that is the sweet spot for mass production. Factories love the middle of that curve. It's predictable, it's profitable, the engineering is, completely standardized.
But today,
Yeah.
we are ignoring the middle. We're going way off the edge of the map to the extreme frontier of footwear engineering. We were talking about the 6E width.
And this isn't just about big shoes.
No, not at all. And I want to be clear about that. This is a deep dive into a really specific manufacturing challenge.
Yeah.
How do you build structural integrity for a foot that just completely defies all the normal standards?
And we should mention, we're pulling from a pretty dense technical report on anthropometric engineering and also some catalog specs from a retailer, DT Footwear, that specializes in this.
Right. And what I realized from reading that is that for the person who needs a true 6E fit, this is not about fashion.
Oh, not even close. It's about mobility. It's about preventing serious medical issues and avoiding something we're going to talk a lot about today, the mushroom effect.
It sounds cute, but it's not. So here's the mission. We are going to unpack the math behind 6E, dissect that mushroom effect, and look at 3 key manufacturers, Apis, Drew, and Haas Bootcumber, who are actually solving these problems.
And I'm glad you're starting with the math, because there is a huge misconception out there about what 6E even means.
I'll admit it, I fell for it. When I saw 6E, my brain just immediately went, okay, the shoe is 6 inches wide. It just seems logical.
It does, and you see that myth everywhere online. But if a shoe were actually 6 inches wide on the inside, you'd be wearing a snowshoe. I mean, it would be unwearable.
Okay, so let's bust the myth. What are the real dimensions we're dealing with?
Let's use a standard men's size 10 as our baseline. It's a common size. A medium, or D, width in that size is about 3.78 across the ball of the foot.
So just under 4 inches, that's normal.
Right. Call it 3.85 inches. Now, that same size 10, in a true 6E, it's just under 4.38, around 4.44 inches.
Wait, that's it. So we're talking about a difference of what, just over half an inch?
Roughly, yeah. A little more than half an inch of extra platform width.
That sounds like, I have to be honest, why is half an inch such a big deal that it requires this whole engineering deep dive?
Because you're thinking of it like a flat line. You have to think about it in terms of biomechanics, surface area.
Yeah.
That half inch represents a massive increase in the platform that's holding you up. Think back to high school physics, the pressure formula.
Oh boy. Pressure equals force over area. P equals F over A.
You got it. So if you have a wide foot and you cram it onto that smaller 3.8-inch base, you're concentrating all your body weight, all that force, onto a surface that's too small. The pressure per square inch goes way up.
And that pressure has to go somewhere.
Exactly. It goes into your bones, it goes into your skin, it creates ulcers. But if you widen that base by that tiny half inch, you spread that force out, that is the difference between walking comfortably and developing chronic wounds.
So it's not just about fitting in the shoe. It's about the physics of what's underneath you.
Precisely. And that brings us to the manufacturing cheats, the whole true versus false 6E debate.
Right. This was the part of the research that really surprised me. The idea that there are, like, counterfeit wide sizes.
Structurally dishonest is maybe a better term. This is where we get into that mushroom effect.
It sounds like a Mario Kart power-up.
It's definitely not a power-up. It's the shoe industry's dirty little secret. See, the most expensive part of making a shoe is the mold. Specifically, the last, the 3D form, and the outsole mold you pour the rubber into.
And you need a new set of molds for every single size and width.
Thousands and thousands of dollars per size. So if you're a cheaper brand and you want to say you sell a wide shoe, you don't want to pay for a new, wider rubber mold.
So what do?
They cheat. They take a standard D-width sole and just stitch a bigger, baggier fabric upper onto it.
So they make the tent bigger, but the floor stays the same size.
That is the perfect analogy. And when a 6E foot gets in there, it just spills over the edge of that rubber sole. It mushrooms out.
Like a muffin top.
The structural muffin top. And the consequences are really severe. First, you have zero lateral stability.
What does that mean?
It means if you step on a crack in the sidewalk, there's nothing underneath the outside edge of your foot to stop it from rolling. You're going to sprain your ankle.
That's incredibly dangerous.
It is. and it destroys the shoe. The fabric tears away from the sole because it's under constant tension. Plus, you're creating a massive pressure point where the soft part of your foot is pressing against the hard edge of that sole.
So a true 6E means the company actually bit the bullet and paid for the proper 6E sole mold.
Yes, a dedicated 6E platform from the ground up, and that's why so few brands do it. It's a huge capital investment.
Okay, so we've covered width, but the sources kept talking about volume and depth. That's another dimension to this.
It is, because a 6E foot often isn't just wide, it's also tall.
Tall.
Think about the conditions that often require a 6E shoe. Edema, which is severe swelling, lymphedema, or just a naturally very high instep. The foot is expanding vertically, not just horizontally.
So a wide, flat pancake of a shoe won't work.
Not at all. And that's where you get double depth. The engineers literally lower the floor of the shoe to create an extra 1/4 inch to a 1/2 inch of vertical space inside.
And the inside of the shoe.
Yeah.
It's a whole other world of engineering. The research mentioned that seams can act like razor blades.
That's not an exaggeration, especially for a diabetic foot with neuropathy. You can't feel a blister forming. A normal seam over thousands of steps can literally saw through the skin without you feeling it. So these specialized brands use seamless interiors. The whole inside is lined with soft, padded foam. It's like a protective bubble for the foot.
And that's why you see so many Velcro straps instead of laces, right? For adjustability.
Exactly. If you have edema, your foot swells during the day. It's a moving target. Fixed laces just don't work. You need long Velcro straps or stretchable Lycra that can expand and contract with the fluid in your body.
The shoe has to be dynamic. It has to breathe with you.
It has to.
Okay, so let's get to the heroes of the story. The brand's doing this right. We've got Apis, Haas, and Drew. Let's start with Apis.
Apis is the heavy hitter for severe medical conditions. They're the ones who go up to like a 14E width.
Wow.
So their 6E is, practically their starting point. But their real value proposition is the inserts. An Apis shoe often comes with 3 removable inserts.
3? Why so many?
It's manual volume control. If you're really swollen one day, you take all 3 out for maximum space. The next day, swelling's down, you put 1 or 2 back in to snug up the fit.
Oh, that's really clever. It's modular.
It is. And it's also crucial for fitting a custom AFO brace.
I'm AFO.
Ankle foot orthosis. It's a big, bulky plastic brace. Apis builds their shoes like a bucket deep enough to hold all that hardware, plus your foot.
So Apis is the medical specialist. Now, Haas Boot Co., this one seems like the hardest challenge. A work boot.
It is, because work boots have safety toes. Steel or composite.
And steel definitely does not stretch.
No. And if you put a standard steel cap in a wide boot, it's just going to crush the toes of a 6E foot. It's like a little guillotine in there.
So what's Haas's solution?
They invented something they call the Bubba toe.
Please tell me that's the real name.
It's their proprietary name, yes. But the engineering is serious. They redesigned the whole safety cap to be wider and more bulbous. It creates a 6E space inside the protective toe.
That's brilliant. You get the safety without the crush.
Exactly. And they pair that with super durable, slip-resistant outsoles. They're building an industrial-grade suspension system.
Okay, so we have the medical specialist in Apis, the industrial tank in Haas. Where does Drew fit in?
Drew is the bridge. They're trying to solve the ugly shoe problem.
The aesthetic struggle is real. The sources mentioned the dad shoe stigma.
It is. Nobody wants to wear something that looks like a medical device. Drew makes shoes that have the true 6E platform, the depth, the inserts, but they're designed to look like a normal dress shoe or a casual walker.
So you can go to a wedding or an office and not feel like you're wearing orthopedic gear.
You can blend in. They're balancing the biomechanics with the social need for normalcy.
And that social aspect is huge. It feels isolating, I imagine, to be completely ignored by mainstream brands.
It is. You can't just walk into a mall, so the whole buying process is different. It's a digital buy and return cycle.
And this is where a specialized retailer like DT Footwear becomes so important, right?
Absolutely, because they understand the logistics. They know you might have to order 3 pairs to find the one that fits your specific volume. So free shipping, free returns. That's not a perk. It's essential infrastructure.
There was one other thing that struck me. The lifespan of these shoes. The note said 12 to 18 months. That feels really short for an expensive shoe.
It does, but you have to remember the forces involved. A wide foot is constantly pushing outwards, trying to flatten the shoe.
You're destroying it from the inside out.
Exactly. The tread on the bottom might look fine, but inside, the foam is crushed and the shank is fatigued. The structural integrity is gone.
So you have to be disciplined about replacing them, even if they still look okay.
If you wait until there's a hole in the sole, you've been walking on a compromised, unsafe platform for months.
This has been really eye-opening. We started with this simple curve and ended up in biomechanics and material science.
It really is a feat of engineering. A true 6E shoe is a sophisticated tool. It's a stable platform, just under 4.5 inches wide for that size 10, designed to protect the foot from the ground and from itself.
And without these brands, Apis, Haas, Drew making that investment, a whole part of the population just loses their independence.
That's the bottom line. It's about being able to go to the grocery store to live your life without pain.
So what's the final thought here for someone listening?
Well, for now, it's about trusting the engineering, not just a label. Measure your feet. But the bigger picture, the future really should be 3D scanned, bespoke manufacturing.
Printing a shoe that's a perfect map of your individual foot.
Exactly. No more sizes, just your fit. You scan your foot, a machine prints a sole that matches your width, your arch, your volume perfectly.
That's the dream.
But until that technology is affordable, the true 6E is the most critical tool in the closet. It's a lifesaver.
A bridge to the future. Well, there you have it. Go check your width, everyone. The engineering you need might surprise you. Thanks for walking us through this.
My pleasure.